Hello guys, welcome to the Bright Agent. Now, my long-awaited video on isotopes that I mentioned in the previous video. You now may be wondering, what are isotopes? Well, isotopes are essentially taking an element and then seeing that there's a different number of neutrons. We'll dive in straight into an example. Protium. Protium is the most abundant version or isotope of hydrogen, and is even included in the periodic table. Just note that just because there are isotopes of elements doesn't mean that they'll appear in the periodic table as well, since it will only do one isotope per element in the periodic table, meaning that even if there's like 5 or 4 or even 3 of them, then the periodic table will only include one, as in the most abundant one that there is, and hopefully one which isn't unstable or radioactive, as we'll get to later. Now, diving into protium. Protium has 1 proton, but 0 neutrons. And then there's another isotope of that hydrogen, the most abundant one, which is deuterium, which is the next most abundant. Deuterium is literally still an isotope of hydrogen. It's still hydrogen. It's just because it has 2 neutrons and 1 proton. Remember that for isotopes, the number of protons do not change, because if it did, it would become another element. For example, if I was somehow to add another proton to hydrogen, it would become helium. So, it's not protons, and neither is it electrons. It is the amount of neutrons. This is very important. Now, deuterium, as I said, has 1 proton and 1 neutron. Now, we'll move on to tritium, which is another isotope of hydrogen. Now, tritium has 1 proton. It still has 1 proton because it's still hydrogen, but has 2 neutrons. So essentially, those are the 3 types or isotopes of hydrogen. So protium is just your standard hydrogen. You can essentially just use it in things like hydrogen gas or whatever. You can use it in factory working, essentially speaking. Now, many of you might not need to learn the properties of the isotopes of hydrogen specifically, but I know that some exam boards might do so in exams or mocks or past papers, so I'm just going to say it for those people out there. Now, deuterium is used in heavy water. You may have seen some videos such as the Action Lab on Nile Red that use put deuterium in water, and that is heavy water, because water consists of H2O, but the H in this instance is protium, which, as I said before, is the most abundant isotope of hydrogen. Now, if you add deuterium, it will make the water even heavier, and the reason why you can't add tritium is because tritium is used for radioactive purposes. It's also the most rare isotope of hydrogen and can just lead to severe complications in your body, which obviously we don't want. Tritium, as I briefly stated just a few seconds ago, is used for radioactive purpose, for example lighting, like indicating where something's there in the dark, so that way everyone can see it. It's sometimes even used on signs on roads, or even for advertising. Those are just a few examples, but the reason why I decided to give the most well-known example is so that way you can understand isotopes better. So essentially, if you look at protium, deuterium, and tritium, they are still hydrogen. They are still isotopes of hydrogen. The only difference that happens is the amount of neutrons they have. In addition, just remember that some isotopes can be radioactive. So you have to be very, very careful if you ever come across a radioactive isotope, be in work or school or whatever circumstance that you're in. So learning about isotopes is beneficial because it just is a change to the mass number. So if you look at the mass number in an exam and it involves an isotope and not the most abundant element that's stated in the periodic table, the mass number will change, but you won't use the most abundant one. For example, chlorine has a mass number of 35.5. There could be isotopes which involve it being 36 or 37.5. Now, the mass number will change because there's added neutrons to isotopes most of the time. So all you have to do is just look at the mass number of that isotope, and if it's something involving moles, then you will just have to add it to, you either have to divide it to find concentration or moles or whatever you're trying to work out, or you'll just try to find the relative atomic mass, which means you just add up the masses in that equation. In rare instances, it will involve isotopes added together with your regular elements, but often it will just use the most abundant element in the periodic table. So isotopes are still important to learn about, but once you learn about them, they're pretty easy to deal with in basically any case. And it also kind of connects into radioactivity, since some isotopes, as I said, are radioactive or unstable, meaning that they have an unstable nucleus, and they just decay over time. That's a bit more of a physics thing, but that's what some isotopes can do. Now, I hope you enjoyed this video. Be bright, stay right, and have a good day. Ensure you like and subscribe, and also comment so I can find ways to make better videos and for you to engage with all the subjects more.